Hey guys, it's Tiffany. Today, I'm going to show you how to work with negative fractions.
Negative fraction operations. Things you need to know to solve negative fraction operations are you need to know how to add, subtract, multiply, and divide fractions. When I say fractions here, I mean regular positive fractions. You also need to know how to add, subtract, multiply, and divide integers. Let's move into example number 1. Example number 1. Negative 5/8 plus 6/10. Okay, like I just explained in the last slide, you need to know how to work with fractions. So let's ignore the negative sign for a minute and pretend like we just have 5/8 plus 6/10. You need to remember, when you have fractions, in order to add them, you have to have a common denominator. So before we can do anything, we need to create a common denominator. And we're going to do all of this while ignoring the negative sign that's in front of 5/8. So we need to get a common denominator for the 8 and the 10, which the least common denominator would be 40. But you could also use 80. A lot of people like to just multiply the two denominators together to get whatever answer and let that answer be your new denominator. That will always work. The only problem with that is sometimes you're going to end up with a really big number. If your denominators are already kind of big, you're going to end up with a really big number and you're going to have to simplify at the end, and it's just going to make more room for error. There's nothing wrong with it, but you just have to keep in mind you might be dealing with some large numbers. I'm going to use 40 since it's a smaller common factor. And I'm moving quickly here because I'm assuming that you already know how to do this. If you don't know how to do this, you need to go check out my video on how to add and subtract fractions. Okay, so my new denominator, I just decided is going to be 40. So I'm going to rewrite both fractions with the denominator of 40. To go from 8 to 40, I multiplied 8 by 5, so that means I need to do the same on the top. My numerator is going to become 25. I'm adding. To go from 10 to 40, I had to multiply by 4. I'm going to do the same on top. My numerator is going to become 24. Now I'm going to add my negative sign back in front of my first fraction, so it's going to become negative 25 over 40. There we go. Now I'm going to draw an equal sign and rewrite my denominator. It's going to become 40 just over here, and this is really the same step you would take when you're adding fractions. The denominator stays the same. Here's the part that's different. I'm going to treat my numerators like their own problem. I'm going to treat them like a regular problem with integers. I'm going to rewrite over here what I'm pretending like this problem originally was. I guess you could think of it as. I'm going to write negative 25 plus 24. So I'm going to treat this like its own problem, not worrying about the denominator. And I know that I have two separate ways that I can solve this. If you go back to my adding and subtracting integers video, you'll see the two ways of solving integers like this. One is going to be using the absolute value method. The other way is going to be using the number line. Either way you do it, you're going to end up with -1 here. So I'm going to put that in, and that's going to be my answer. My answer for this whole problem is -1 over 40. That's the answer. So all I did was get common denominators, keep my denominator the same because that would follow the rule for adding fractions. Your denominator stays the same. Then I treat my numerators like its own regular integer problem, and I end up with -1 over 40. Let's move on to example number 2. Example number 2, I have -9 over 15 minus negative 1 over 5. A lot of times if you have a subtraction sign and then you have a negative number that you're subtracting, you're going to see that number that you're subtracting inside parentheses, and that's because it can begin to look a little confusing when you see two negatives like touching right next to each other. That kind of looks weird. You're kind of like, what's going on? So you know, when you're looking in your book or on a worksheet or wherever you're doing your work, you're going to see parentheses around that second number a lot of the time. It's not required. It doesn't have to be there, so sometimes you won't see it, but I'm just explaining why they put it there. It's just for clarification. Okay, so again, I'm going to follow the rules for subtracting fractions. The rules for subtracting fractions say that I have to have common denominators. So right now, I'm going to ignore my negative signs, and I'm going to rewrite these fractions, but with a common denominator. 15 is going to be my common denominator. This side is just going to end up being the same. And this side, to go from the 5 to the 15, I had to multiply by 3, so I do the same to the numerator, and so my numerator becomes 3. Now, I'm going to add my negatives back. You may have noticed that the negative sign looks like it's like touching the denominator on this side more so than the numerator. That does not matter at all. If there's a negative somewhere on that thing, the whole number is negative. It doesn't matter if like it's drawn above the line or below the line or right in front of the line. That whole fraction is negative, okay? I rewrote it in above the line. That's really not a big deal. Okay, so now, just like we did in the last example, we're going to complete the rules for subtraction, but last time we had addition. We're just going to complete the rules for subtraction here of a fraction, which would mean my denominators remain the same, and I'm going to treat my numerators like their own problem. That own problem is going to look like this: negative 9 minus negative 3, and I can put this in parentheses for clarification. If you remember the rules for subtracting integers that I have in that other video, you're going to know that this is the same thing as negative 9 plus 3, which is the same thing as negative 6. So my numerator becomes negative 6, and then I check to see if I can simplify this at all. Is there a number that can go into both 6 and 15? 3 can. 3 can go into 6 2 times, and it can go into 15 5 times. It's still negative. So my answer to example number 2 is negative 2/5. Let's move on to example number 3. I threw something in here that's a little different. I did not put a negative sign on either of the fractions this time. I did this on purpose. A lot of times students will be in the middle of their lesson solving problems, and all of a sudden they have a problem that has no negative signs, and they think because the lesson that they're on is working with negative numbers, they need to do something weird or something different than usual to solve the problem. Please be careful. Sometimes you're going to have a problem that does not have a negative sign, and guess what? That is just a regular problem. This is just a regular fraction problem, like maybe you would have learned in 5th grade or so. Okay, so don't get confused. I did that on purpose here. So we're just going to solve this like a regular fraction problem, because sometimes that's going to happen. You're going to get a regular problem that has no negative numbers in it. And don't think too hard about it. So if you remember the rule for multiplying fractions, all you do is you multiply straight across with your numerators, and you're going to get 1 here. And then you multiply straight across with your denominator. So 9 times 2 is 18. The answer to example number 3 is 1/18. Let's move on to example number 4. Example number 4. This time we're dividing, okay? We need to remember the rules for division of fraction. So again, I'm going to ignore this negative sign right now, and I'm just going to remember my rules for dividing fractions. And those rules say keep it, change it, flip it. And so I'm going to keep my 4/15 the same. I'm going to change my division sign to multiplication, and I'm going to flip my 1/5 to its reciprocal, which is going to be 5 over 1. And now I'm going to solve this like a regular multiplication problem, a regular multiplication of fractions problem, I should say, which would be 4 times 5, which is 20, and then 15 times 1, which is 15. This is still negative because this negative could be brought down right here, and again, when you're multiplying, you're going to use this negative sign only one time. You're not going to treat the 4 as negative and the 15 as negative when you're multiplying across. So we're just going to choose the 4 and say 4 times 5, and I'm remembering the rules for multiplying negative integers, and the rule says that one of your terms is going to be negative, one is going to be positive, and the rules for multiplying negative integers say that 2 of your terms in your problem are going to be negative and 1 is going to be positive. So if this one's negative and this one's positive, this one must be negative. And down here, these are just all going to be positive, but this negative sign is going to mean that this entire answer is negative. Okay? Now, this is an improper fraction, so I'm going to make it look a little better. This is when I divide 15 into 20, and I get 1 and 5/15, and this is negative still. And my 5/15 can simplify, and it simplifies to 1/3. So the answer to example number 4 is -1 and 1/3. That was my last example. Thanks for watching.
If you liked this video, don't forget to click like, then head over to supereasymath.com for more math tutorials, printable video notes, worksheets, and more.